Hi, let's discuss Chomsky hierarchy. There are four types of language. One is type 0. Type 0 is recursive enamel language. Type 1 is context sensitive language. Type 2 is context free language. Type 3 is regular language. And for every language there is specified grammar. For recursive enumerable language there is recursive enumerable grammar. For context sensitive language there is context sensitive grammar. For context free language there is context free grammar. For regular language there is regular grammar. Let's discuss what is difference between these grammar. First is recursive enumerable grammar, or you can say type 0 grammar. If every production is in the form of alpha tends to beta and alpha belongs to V plus T positive closure and beta belongs to V plus T clean closure. V is for variable, T is for terminal. Left side there can be variable plus terminal, but minimum there should be at least one variable or one terminal, and right side it can be any combination of variable and terminal including epsilon. One example of recursive enumerable grammar is AA tends to BB or epsilon. You can see here left side terminal is allowed. In recursive enumerable grammar and in context sensitive grammar, left side terminal is allowed, terminal is possible. But in context free grammar and regular grammar, left side only variable is allowed. And here epsilon is allowed because beta belongs to V plus T clean closure. Clean closure means it will be minimum epsilon, then it can be variable, it can be terminal, it can be any combination of variable and terminal. Every problem which is executable or decidable is recursive enumerable language. Next is context sensitive grammar. If every production is in the form of alpha tends to beta and alpha beta both belongs to V plus T positive closure. Here beta cannot be epsilon, right side epsilon is not possible, and here left side terminal is allowed. Both alpha beta that belongs to V plus T positive closure and alpha length should be less than equal to beta length. Let's see one example. From AA you can derive BAB or BB. What is difference between recursive enumerable grammar and context sensitive grammar? In both, alpha belongs to B plus T positive closure, but here beta belongs to B plus T clean closure. Here beta belongs to B plus T positive closure. Means in recursive enumerable grammar, epsilon is allowed. In context sensitive grammar, epsilon is not allowed. And in both, left side terminal is allowed. Context sensitive grammar doesn't contain any production to generate epsilon. We cannot generate epsilon from context sensitive grammar. Every programming language is context sensitive grammar. These are some examples of context sensitive grammar: A power n, B power n, C power n greater than equal to 1. If it will be greater than equal to 0, it will be not context sensitive, it will be recursive enumerable. And W belongs to A plus B positive closure. If it will be A plus B clean closure, it will be recursive enumerable. In context sensitive, minimum string length is 1. It will not contain epsilon or length 0 string. Next language, context free grammar. If every production is in the form of alpha tends to beta and alpha belongs to variable, beta belongs to V plus T clean closure. In previously we see in context sensitive and recursive enumerable grammar, alpha can be V plus T positive closure. Means in left side terminal is allowed. But here left side only variable is allowed and right side beta that can be any combination of variable and terminal. Here it is clean closure, so epsilon is also allowed. Let's see one example. From S you can derive ASV or epsilon. This is a context free grammar. DCFL is used to define programming language. DCFL means deterministic context free language is used to define programming language. By using context free grammar, we can only define, but context sensitive, you can run a programming language. So every programming language is context sensitive, but by context free language, you can only define programming language. Next, regular grammar. If every production is in the form of alpha tends to x, beta or x, or alpha tends to beta x or x, then it is regular grammar. Here alpha and beta belongs to variable and x belongs to terminal clean closure. It can be epsilon, it can be any combination of terminal. And here alpha beta belongs to variable. And left side there will be always variable. Terminal is not allowed. In context free and in regular grammar, left side only variable is allowed. Right side variable plus terminal can be. And regular grammar, it can be in any of one form. Either it will be x beta or beta x. Here is one example. H tends to as or epsilon. Next, type of regular grammar. It can be of two types. One is right linear grammar, another is left linear grammar. This is an example of right linear grammar where variable is at right side. And this is an example of left linear grammar where variable is at left side. This example is a right linear grammar. If you are writing S tends to SA or epsilon, then this is a left linear grammar. Here variable is at left side. If variable is at right side, it is a right linear grammar. If variable is at left side, it is a left linear grammar. Right linear grammar has right associative and left linear grammar has left associative. Every regular grammar is unambiguous. Ambiguous means if you can generate more than one parse for one string. But every regular grammar is unambiguous means there will be just one parse for one string. Every regular grammar is also context-free grammar as regular language is subset of context-free language. So every regular grammar is also context-free grammar. In next lecture, I will discuss more detail about right linear grammar and left linear grammar. If any doubt, just ask me in comment. Thank you.